Alright, so in this video I'm going to be talking about page 5 of the notes packet. This is where we start solving inequalities. So far we've mostly been working with pretty simple inequalities, things like x is greater than or equal to 2 or y is less than 3. But you can also have multi-step inequalities where there's multiple things happening on both sides of the inequality, and you need to figure out what is the simplest solution. Like what is the solution? What is the set of numbers that actually make that inequality true? So for example, we might have something like 3 times the number m minus 5 is greater than negative 2. And we can write that 3m minus 5 is greater than 2. Or we might have a number multiplied by 7 is less than or equal to 14. So we might have 7x is less than or equal to 14. And we want to figure out, well, what values of m and x solve these inequalities. And we can actually solve them, for the most part, in the same way that we solved equations in Unit 1. So we're drawing from that knowledge base that if we have 3m minus 5 is greater than 2, well, we can solve that by multiplying by adding 5 to both sides, and you get 3m is greater than 7, which means, and then we can divide both sides by 3, meaning that m is greater than 7 over 3. If we go on our number line, 7 over 3 is going to be there, and graph it with an open circle. Because it's greater than, we know it's going to be over to the right. And then if we want to check our answer, we're going to take our original inequality, so 3m minus 5, and we're going to plug in a number to the left and to the right. And if we've done this right, then the number that we plug into the left should result in an inequality that is not true, but any number we plug into the right should result in an inequality that is true. So let's try a number to the left for our solution, 0. So it'd be 3 times 0 minus 5 is greater than 2. 3 times 0 is 0. Negative 5 is greater than 2, which we know is not true. And that makes sense, right? 0 is not part of our solution set, so it should be not true. But if we instead plug in 3 times 3 minus 5 is greater than 2. Well, that's 9 minus 5 is greater than 2, which is 4 is greater than 2, which that part is true. So we know we're on the right track there. All right. Over here, if we have 7x is less than or equal to 14, well, that means x has to be less than or equal to 7 if we divide both sides by 7. We can graph that starting at 7 now with a filled in circle going to the left. If we want to check our answers, we want to plug in some number on both sides and see if they're true. So over here, if we plug in 0, we'll get 7 times 0 is less than or equal to 14. That's 0 is less than or equal to 14, which is true. So that makes sense, right? If we're here, we're in the solution set, so the inequality should work. You know, if we try something over here, if we try 8, right, where we're now outside of the solution set, well, that would be, oh, sorry, not 7. That should be a 2, right? 14 divided by 7 is 2, not 7. Still early when I'm recording this. So we try something here. Notice how 0 is still in the solution set, so 0 will still work. But let's try something like 3. 7 times 3 is less than or equal to 14. 21 is less than or equal to 14, which it is not. So 3 not in our solution set, and therefore gives us a false inequality. All right, now this is super, super important. The one major difference between solving inequalities and solving equations, so we're going to do the same steps, but the one additional thing we need to think of if you multiply or divide by a negative number, you need to flip the direction of the inequality. So let's see what I mean by that. So we're trying to solve this inequality over here. We're going to add 3 on both sides. 2x is greater than 8. That means x has to be greater than 4, dividing both sides by 2. All right, so that means we got to go open circle here. We go this way. If we check a number to the left, well, 2 times 0 minus 3 is greater than 5. 2 times 0 is 0, minus 3 is minus 3. Minus 3 is not greater than 5, which is what we should see if we plug in 0. I'm going to use a red X here. Just say nope. But if we plug in 5, 2 times 5 minus 3 is greater than 5. 10 minus 3 is greater than 5. 7 is greater than 5, which it is. So that's how we have some sort of faith that what we're doing is correct, right? Because if our solution is reasonable, then anything we plug in inside the solution set should give us a true inequality. Anything outside of it should not. All right. If we look at example 4 over here, the major difference is over here we have a positive 2x, over here we have a negative 2x, and we're going to need to follow our rule. If you multiply or divide by a negative, flip the direction of the inequality. So let's start by, it starts the same way. You add 3 on both sides, and you get negative 2x is greater than 8. And we divide by negative 2, divide by negative 2. So we're going to get x and 4 still, or we're going to get negative 4, sorry. But now we need to make it a less than instead of a greater than sign. So it's going to be, put a line there. Can go to the left. And now if we check our answer, if we plug in something to the left of that, or if we plug in, say, negative 5, well, negative 2 times negative 5 minus 3 is greater than 5. Negative 2 times negative 5, well, that's 10. Minus 3 is greater than 5. 7 is greater than 5. So that works. If we plug in 0 over here, that's going to be negative 2 times 0. Minus 3 is greater than 5. Minus 3 is greater than 5. Yes, which it is. Which it is not, sorry. Negative 3 is not greater than 5. So we know that 0 is not part of our solution set. And that's how it should be. So we can see that when we flipped the inequality, suddenly plugging it back in, it still worked. All right, well, we'll see how far we get in class today.